tentando fazer. E o melhor é o... De composição, na verdade, não é. Porque você começar a funcionar,
Alô? Oi, pessoal. Boa tarde, tudo bom? Obrigada pela presença de todos. A gente vai iniciar o evento daqui a uns minutos, mas queria só avisá-los de que já tem um coffee aqui fora, tá bom? Fiquem à vontade, tem café, tem alguns lanches. A gente só não pode entrar no auditório com comida ou bebida, mas fiquem à vontade, está ali à disposição de vocês ali fora, tá bom? A gente retorna às 6. Obrigada.
pessoal escutando, como se fosse, sei lá, um vídeo no YouTube de um... Eu tô esperando que eu vou entender.
Eu tô chegando hoje, é minha segunda temporada.
Não, materiais. Eu queria... Porque ele queria fazer qualquer coisa, mas... Tipo, eu acho que se ele fosse entrar agora na faculdade, eu acho que ele não entraria em engenharia. Talvez ele fizesse nada de engenharia. Ele vai, tipo, largar o bagulho agora. Fez 2 anos. Na real, a gente só fez ele, só foi aprovado em 1.
Mas é que a gente não tem, se tivesse até mesmo a rede, o celular com rede talvez conseguiria fazer a transmissão. Tá? Mentira. Não, meu carregador é italiano.
Agora é só aguardar a resposta. Um abraço.
Olá, boa noite a todos. Nós da Swiss Next Brasil agradecemos a presença de todos aqui. Como nós informamos, né, o evento ele vai ser todo feito em inglês. Então, também em respeito ao nosso convidado suíço, eu vou agora switch to English. So, welcome everyone. I'm Silvia Romanelli, Head of Entrepreneurship and Innovation at Swiss Next Brazil. Swiss Next is a public-private initiative of Switzerland's State Secretariat for Education, Research and Innovation. So we are part of a global network with offices in the US, India, China, and we work with local expertise, but globally, to connect Switzerland to the most innovative hubs in the world. So whatever is related to education, research, entrepreneurship, we are here to foster academic collaborations among Swiss and Brazilian universities. We are also here to organize events like this and workshops connecting both innovation ecosystems. We also support the internationalization efforts of Swiss startups that are aiming to enter the Brazilian market. And we also run a program called Academia Industry Training, which is made for Swiss and Brazilian science entrepreneurs who have very potential research that could be applied to the market. But the scientists, the researchers are struggling in trying to take the idea from the lab to the market. So we also offer, in partnership with CNPq, a 2-week training for those entrepreneurs. Actually, the call is now open on our website, so I highly encourage you to take a look and also come to me afterwards. But anyway, today we have a very diverse audience, I think. Just to have an idea, a sense of who you are, please raise your hand if you are a researcher, student, or, okay. If you are a professor, okay. If you are an entrepreneur, good. If you have already done any research or conducted a study in partnership with a Swiss university, okay. We have many Swiss alumni today, so which is really nice. Okay, but one thing that we are all aware of is that you are all interested in robotics, which is the subject of our discussion tonight. And we have the pleasure to have Professor Roland Siegwart tonight with us. He's a full professor. It's a big, not a mini bio because he has lots of experience, but he's a full professor of autonomous systems at ETH Zurich. He was also a professor at EPFL in Lausanne. He's a founding co-director of the Swiss Zurich Foundation. He was the vice president of research and corporate relations in the ETH executive board. And we have the pleasure to have him tonight, so he will share some of his expertise and his perspective also on the development of the innovation ecosystem in Switzerland and his experience on robotics. But we can't go on without thanking very much the University of São Paulo, especially Professor Liedi, who is here tonight. Please come and join us. Thank you very much for having us at your home.
Thank you very much. I'd like to welcome Professor Siegwart. It's a great pleasure to receive you here at Polytechnic School of the University of São Paulo. Professor Siegwart is a full professor at ETH Zurich, Switzerland, where our founder, Professor Paula Souza, studied, and he copied the structure of your school to bring to Brazil, and he believed that it was a very good model of for engineering school to support the industry, the necessary industry development that we needed at that time in the late of 19th century. Professor Siegwart, Siegwart's research is focused on AI, and this is a very important tool for our future, for our life, to make our life easier. Thank you very much for coming. I hope you enjoy your stay in Brazil. And we have here something about our school.
Wow, wonderful.
Thank you very much for coming. You are very welcome. Thank you.
Thanks very much.
This is yours.
Thanks very much for this nice introduction. And I learned also that there is obviously quite some link between the two universities, and indeed the ETH Zurich was founded with not only two tasks. It's not only about research and education, but also about technology transfer. And I will show some examples also in my presentation. So I will speak about autonomous mobile robots, and I have only 20 minutes, so I will have to rush through the slides. But let me first start with robotics in general. We probably all know these robots which are building our cars. They're doing this 24 hours a day, very reliable, and in these tasks, robots are better than humans. They can much more precisely solder or machine the cars. They are not getting tired, but they can not improvise. So they have to be in a very structured environment. The car is always moving in exactly the same, and then the robot can do a good job. I will not speak about these robots, which are already well established in the industry. So there is about 350 to 400,000 of these robots installed every day. The majority today is in China. It's 30% of these robots are installed in China, and not because the labor costs in China are high, but because these robots can do these jobs much better. But I will speak about this new type of robots, which were often called servers or personal robots, which will gradually, hopefully, appear in our daily environment. Some of you might know this video, which was watched a lot on YouTube. It's from Boston Dynamics. It's a robot which intends or shows here that might be that he can clean up your kitchen. Unfortunately, I have to disappoint you. This is not reality today. This robot is real. But all the work in the kitchen is actually teleoperated and very precisely. Students can learn from perception, design of an entire system, up to controlling and artificial intelligence and programming. So our students in the last year of the bachelor, they can select a focus project. So not all of them do a project, but some of them do a little bit more project and less lecture. And one example was this robot, which we call BeachBot. This was initiated by Disney, which has a research lab on the campus at ETH in Zurich. And they wanted to have a robot which makes drawing in the sand on the beach, because they have some hotels on the beach. And so the students had to build a robot which is able to dig into the sand and make nice drawings, so that you give the robot a drawing, and then the robot repeats this on the sand. So you have here some elements that you can select how many elements dig in the sand. And then eventually, if the robot is precisely controlled, it knows exactly where it is, and it knows where it is thanks to these 3 or 4 pillars, which are reflectors, which can be seen by the laser on board. So you can then put them randomly, and in relation to these pillars, the robot can then actually draw such a drawing in the beach, and you can see that it's very precise. And you can imagine that is, for a human, it would not be so easy. So some tasks robots can do better than us, and it's probably useful to use these robots in these situations. These projects are actually educational projects. So they don't have to always be really have a purpose, but they should have a vision to do something new. And so another question was, once the students asked themselves, can we build a car or something like a car with wheels, which can also roll on the walls? And so what they come up with a design is actually a car-like system. It's about this size. But it's combined with propellers. So it's like a hybrid between a helicopter and a car. And the propellers can be oriented in different directions. So with this, they can actually generate forces against the wall. They can generate forces to lift more or less against the gravity force, and they can generate a propulsion force. Now, if you have a sensor which always measures how the robot is oriented in space, then you can appropriately control the propellers. And then, instead of being stopped at the wall, the robot just adapts its propeller and then automatically continues on the wall. So all of a sudden you have a system which can go on the wall. This was more a challenge for the student to see, is this feasible? Interestingly, there were the civil engineers coming immediately and say, yes, we need something like this. Because from time to time we have to inspect bridges with sensors which are in contact, and this could be an ideal solution. Another field where we are doing since quite a while some work, and now especially continued by Marco Hutter, a colleague of mine, a former PhD student of mine, is walking robots. Walking robots, in the beginning we thought, ask our question, can we build a robot which is as agile, as dynamic and as fast as a human, or in this case rather as a dog? And this was actually the inspiration. If you see, this is a jumpy dog. A lot of dogs can really do crazy things. There are also humans that can even walk for a short moment on a wall or make big jumps. Now, if you look at nature, which evolved our ability to walk over millions of years, you can learn a couple of elements. For example, we can learn that we have muscles, but we have also elasticity in the whole system. This is mainly the tendons, but also the muscles. And this helps a lot. For example, if we would not have this, and if I would jump down from here, the whole force, the impact force, will directly go in my spine. But the elasticity, which is like a spring, can actually make the force much smaller. On the other side, this elasticity helps also to recover energy. And the third thing is the elasticity allows us also to measure the contact force. And so we then developed a system which is similar to the human body, but of course is technically built. So you have a motor here, a linear motor. Oh, sorry. Oops. A linear motor, and then a spring after the motor. And with this deformation of the spring, you can actually store energy and release it again. So you can recover about 70% of the energy which will be lost. The deformation of the spring is directly a measurement of the contact force. And you can actually also protect the gearbox which is behind. Now this, of course, you can integrate in a mechanical system. You can integrate directly in a motor. So we have a motor and reduction gear, and then a spring. And then this robot is much more adaptable to different terrains and can start to walk up stairs, can do jumps, and it's especially compared with other robots. Also, some of these first human robots which came from Japan, they are rigid. But these robots are somewhat soft. So if their underground is not fully flat, the leg will automatically adapt to the environment. And eventually, if you do this nicely and integrate this with sensor systems, as you can see here, which was then developed further by a startup company, you can go and do inspection on oil and gas platforms in the ocean. So you have sensors that can look around, and this robot, in contrast to a wheeled system, can really go upstairs, can typically move wherever humans can move, and can then take the job, which is tedious and which is not really nice of humans, and sometimes it's even dangerous for humans, and so robots can do 3D mapping and do inspection. The biggest part of our activity in the last years in my lab was mainly on flying platforms. And we actually realized the first flying quadrotor, which today everybody knows, with 4 propellers. This was only about 15 years ago. Now, why was it all of a sudden possible? The idea, the concept was around longer. But all of a sudden, there was sensors available which allowed to control this. This is mainly the accelerometer and angular rotational speed measurement. And you need this in order to control these systems. And then all of a sudden we were able to actually bring this in the air, have enough calculation power and also the appropriate motors. And this first prototype done by my PhD student Samir about 15 years ago was even has some obstacle avoidance with ultrasound sensors. Now these helicopters are still limited in flight time. Helicopter type flying, rotary wings as they're called, are highly inefficient. So we were immediately then also starting to think about, can we make these systems more efficient? And we started with solar airplanes, and we started also with combination between rotary wing, helicopter type, and fixed wing. And if you combine this, you can actually have the advantage of a helicopter that you can land and get off at a certain specific point. You then don't need a rollway, but you can still have the efficiency of a fixed wing, which is about 10 times higher and better than rotary wing. And this is what students also did with a focus project at the end of the bachelor. They were so excited, some of them, they continued during the master, and today they have a company which is called Wingtra, selling these type of robots all over the world. I'm pretty sure there is already some of them also in Brazil. So they can take off vertically and then go in a fixed wing mode. And so they can fly about 1 hour, in contrast to a rotary wing, which today with batteries can fly probably about 10 minutes. So this allows really to go in new fields, especially in agriculture and the big fields in Brazil. I think are ideal candidates for these systems. Of course, we tried even harder and said, can we fly forever? So having an airplane in the air and stay forever there. And we were able to show that this is feasible. 2008, we showed the first time 24-hour flights, non-stop with solar cells charging the batteries, and during the night we took the energy from the batteries. And then we did even an improved system, which is about 6 meters wingspan, 6 kilograms in weight. Half of it is typically batteries, which flew in 2015, 81 hours, non-stop in Switzerland. And then this system was used for a mission with the people from Earth Sciences, which are interested in doing measurements in Greenland on the glaciers. So from the mission station, they have to go up a couple hundred kilometers up to the glaciers. If they have to do this with regular airplanes, they have to bring up all the fuel there. It's very difficult. It's sometimes victims on the surface here with the civil engineers, because they want to see if there is some corrosion of the steel in concrete structures. Now, the second thing what mobile robots need is actually some sort of an intelligence. And this is typically done with sensors and then some treatment of the sensors. And I would like to give you only one example. This is visual navigation. Vision is, in a sense, an ideal sensor because it's cheap today. You can buy a camera, a high-resolution camera for a couple $. It's available everywhere, and it has a rich information. But the rich information is also at the counterpoint that it's very difficult to treat it. And the second element is that the vision is a projection from the 3D world on a plane. So you're losing the depth. So you have an image, but you don't know where a certain point on the image is. But imagine that you could probably say, okay, you have stereo camera, but very often this doesn't work for distance far away. But imagine you have a mobile platform, and you just take multiple images. Now you try to find this point in an image from another location, so the robot moves around. And then if you can eventually find the same point, which is the point which is sticking out in the image, then you can actually do some triangulation, and all of a sudden you can actually recover the depth. You can also recover the motion of the robot platform itself. Additionally, only to the camera you're actually missing one parameter, it's the scale. But for recovering the scale, typically you can use an IMU. This is an inertial measurement unit. Again, a sensor which is even cheaper, probably $1. This is the sensor you have in your smartphone, the sensor which detects if you're turning the smartphone and that screen is adapted. Now, if you bring this together, we did this for the flying platforms, and then all of a sudden Google and some others were interested in this because it's also interesting for smartphones. So we started to work with Google, doing the same on tablets and smartphones. You connect, you track features. This is this colored point in the image. This is the IMU, this is the acceleration and the rotational speed. And if you fuse this with the appropriate algorithm, then you can, in real time, on the tablet, calculate the motion. And this motion is calculated in a roughly in plus minus less than 1%. So you know very precisely where you're moving without having external GPS or whatever, only by tracking one camera and the points in the image and combining with IMU. Why now, why is this interesting on a tablet? So I will tell you then later on why could it be interesting for robots. It's more clear probably, robots have to know where they are. But on a tablet, it's interesting exactly for the same as for virtual reality and augmented reality. If you have mirrors or goggles for virtual reality, the camera has, or the image has to be adapted to your head movement. So somebody has to tell the system how your head is moving. And if you want to do this good, only the acceleration is not enough. You have to track. And this new system do exactly this. And if it's well done, then you're okay. If it's not good done, you will get seasick. So if you do this now, not only with the goggles, but also you can do this on your smartphone. With this new smartphone, this features is available. And a team of my lab actually did this for a game for educating people with virtual and augmented reality. And what they can do is actually superimpose on the image you see through the smartphone virtual elements, and here they superimpose a castle, and you can see it looks like the castle is really here, but it's only virtually here, and you can imagine this is nice for gaming, but this can also be nice for education. Actually, they're pushing education, so that people can, kids can actually do some educational games to learn mathematics and physics. In robotics, it's more interested in this direction. You have the same thing. You have a tablet which has a camera and has an IMU. Now, the first time this person has to inspect every day an industrial setting, taking some measurements of valves or probably moving some stuff around. One day he decides, hey, I'm taking the tablet with me. I'm actually doing a map. So the tablet does the map. It's a little bit difficult. See here, based on this tracking of features in the image, and the IMU combined, it knows exactly how it moves. So it can record this, and this recording is then here. The yellow points are the features which are now built in a map. The green is the movement. And now you can hand this over to another system which has also a camera and IMU. It can be a robot. In this case, it's a flying robot. So the flying robot has exactly the same, uses this map, and the day after, the robot does exactly what the human did. So he can actually repeat jobs which are probably not so fun for humans by doing it itself in a simple way by learning or transmitting the map. So with this, coming somewhat to the end, I could speak for a lot of more examples. And I would like coming back to this question, why is it actually difficult, robotics? And some people think that tomorrow we will have robots which are more intelligent, more versatile than humans. I'm pretty sure that this will not be the case. This was prognosis we had already 30 years ago, and the progress was not so fast. So I tried to bring this on one graph. On this side, you have on one side the complexity of the environment. Is it dynamic, three-dimensional? You have to put stuff together which touch each other? This is difficult. And the other thing is then also the interaction. If you have a robot which also only have to move from A to B, a flying platform, typically in the free space it's easy. It has probably some difficulties by landing and getting off the ground, but in between it's easy. But as soon as you have to interact with tactility, you need different type of senses. You have to feel the environment. And this is very difficult. This is the other axis. So coming back to the household task. Interestingly for us, it looks simple. So we assume typically a kid is 10 years old, he can clean up, at least help us to clean up the kitchen. For robots, this is extremely difficult. But driving safely on a freeway, we would probably not let a kid doing this. This is much easier for a robot than, and hopefully at one point even safer than for humans. So if you look the other line, autonomous driving on a freeway is more or less solved. Now the question is, how long will it take to have it fully industrialized and also all the rules? And I think also this will take probably another 5 to 10 years. But a freeway is the simplest case. It's very structured. You have only other cars, you're only moving in one direction, so it's easy. Once you have to have a robot which is going into a city, all of a sudden you have sign of other humans. They give signs. All of a sudden you have different type of, you have probably all of a sudden a horse on the street. And then it's getting more difficult. So the more type of interaction you have, the more difficult it gets. This means that it's quite difficult to make fast progress because it's physical and it's not only computer programs. So probably before I end with a final slide, I think Switzerland has probably a little bit by accident started in a good moment to invest in robotics. We have grown more and more research in mainly at ETH Zurich and EPFL in the field of robotics. And meanwhile, we have also some other universities which have some special fields like medical robotics. This puts us in a very good situation also for technology transfer. And we have also different projects which actually connect these universities. For example, the National Center of Competence in Robotics, where we collaborate with EPFL and university in the Italian-speaking part. Then we have something which is, I like a lot, a project which is called digital fabrication. It's in principle robotics for construction. And there's plenty to do in construction, because construction is sometimes dangerous, not really healthy for humans. Robots can actually do the unhealthy tasks. And this project, which is also the National Center of Competence, was initiated by the architects. And the architects are not per se interested in robotics, but they consider themselves as artists. So they would like to have no restriction how to build buildings. We see all the walls here are flat. This is because our construction is very difficult to have round. But if you have robots, all of a sudden you can think about very different shapes. And there's a really and very interesting interaction with them. All the basic research we did in the last 20 years, and the strong initiative started only about 15, 20 years ago, also brought up a lot of startup companies. I would guess that we have, compared with the density of the population in Switzerland, probably the highest density of startup companies, going from a lot of flying robots, but also rehabilitation robotics, different elements for inspection of system and so on. And interestingly, and this is probably not only linked to robotics, but mainly linked to this visual navigation, meanwhile, more or less all the big IT companies have also research labs in Zurich. And the main reason is that they are looking for young people which are well educated in visual navigation, which is a core part of the whole virtual and augmented reality. So we have Google since quite a while in Zurich. This came actually to Zurich because of something else, because of the map. Google Map was initiated in Zurich because there was a startup a long time ago which built this up. But then later on we had Apple, Microsoft. These companies came a little bit later, Disney Research, and have all of them really a lot of people now there, and they are interacting with the university. I think it pays off if you want you have a specialization in a specific field, then companies will come very often less about the technology, because we are publishing anyway everything. They can also read this in Silicon Valley, but they need the people. They need the people which are educated in the field. With them, this last slide doesn't show, but I can summarize anyway. So yes, robotics is booming, and there is actually sometimes probably a little bit overhype. I hope I showed you also that it's not so easy to make physically interaction robots which can do really much more than what I can do today. For robotics, you need a combination between AI, precision mechanics, a lot of sensing technology. I think Silicon Valley, for example, is not the perfect case for robotics, because you need also precision mechanics, you need sensor technology. I think Switzerland has a really good situation in this field, because we are known for precision mechanics. We have actually also a lot of company in sensing system. What we probably need a little bit more, and there we could look to Silicon Valley, we need a little bit more risk-taking. It's on one side our young people, sometimes they don't want to scale so fast with their company and take a lot of money from investors, because they think, otherwise I get no power anymore. In some fields you have to go fast. And of course, Switzerland, sometimes we have enough people which are investing, but unfortunately up to recently, they mainly invested then in funds in Silicon Valley. More and more, this works also out, and we need this investment in Switzerland. And I'm happy to come back then also in the discussion to what is probably the opportunity for Brazil. I see a lot of opportunity. I had now ready to do the kitchen work, but I can walk them with that. Thanks very much for your interest, and I think we'll go now over to the discussion.
Thank you very much, Professor Siegwart. Now we will continue this discussion. And for doing so, I would like to invite, first of all, Professor Marcelo Becker. He's Associate Professor at University of São Paulo, also an ETH and EPFL alumni, and his areas of research are mainly on robotics and mechatronics. And he will be the moderator of the discussion we will have now. Please take your seat. Also, please join us, Professor Paulo Miagi. He's a full professor here at Poly USP. He works in the area of mechatronics engineering with emphasis on systems automation, and has carried out R&D in industrial automation, robot programming, and control systems design. Thank you for joining us. And Daniel Consalter, he's the CTO of the startup FIT, Finding Instrument Technology. He holds a PhD in applied physics from the Institute of Physics of São Carlos at the University of São Paulo in the field of nuclear magnetic resonance instrumentation. And Daniel is an entrepreneur focused on the development of analytical equipment and solutions in process and quality control in agro. And also has a partnership with Embrapa. And of course, Professor Siegwart will also join us. So I hope you have a good discussion, and please feel free also to join us afterwards for another networking moment with some snacks and drinks outside. So I'll give it the word to you.
Okay. Thank you very much for inviting us to come. It's a pleasure to be here at Polytechnic Institute, University of São Paulo. It's so good to see so many faces, so many friends here. So I try to summarize some topics here for discussion, but later on, feel free to raise your hand and make questions. I think it's a good moment. Okay. So the first question I would like to make for three guys here is about how automation strategy can be adopted or applied by governments, enterprise, and startups. How can they do it to improve the quality of life of our population?
Yes, so meanwhile, I've had 10 years a research lab at EPFL in Lausanne, at the second technical university, and then since about 14 years now in Zurich. We had, in total, about 15 startups coming out of, and then I asked myself, why this happening? I think it's the most important thing is first attract the best people and then give them the freedom so that they can do something. And you have seen these focus projects, which we actually started as educational project, and then all of a sudden we had, meanwhile, about 5 of these projects where startups were generated. We give them students the freedom to work on a project, on a vision. They can decide. We are supervising, advising them, but if they take a wrong decision, it's their decision. We don't interfere in the decisions, and I think this can help a lot. We have plenty of young people which only need a little bit of advice, and if they are good, then they move forward.
Okay. Well, my opinion is that automation is unstoppable and government cannot disturb. I mean, it's always possible that government disturb because it's related with jobs and a lot of problems that robots are stealing jobs, etc. And what the government have to do is to funding incentivize the students to go to make your own startup and invest on base education to prepare the people that the robots will replace their jobs. If you have a job that can be replaced by a robot, you have to be more, you have to study, you have to invest in education to this not happen. Other thing is, as a startup owner, we developed analytic equipment, but now we are developing automation for this analytic analysis because the clients are asking to do. So what we are doing is, I believe 90% of startups are related with automation, are developing automation. They are not using as a tool yet, but they are developing and going to market. I believe it.
Well, I'm also in the area of robotics, so I have some experience in this area. I can tell that, well, this area is very interesting. Professor Siegwart talked about several things very interesting, and show that there are a lot of things that we are really reach very interesting point now. But there are a lot of challenges that we need to consider. For one of the main words of this plenary was autonomous robots. The autonomous is very interesting because it includes not only free decision, or autonomous decision, I don't know. But anyway, if you see the robot like the first slides, something similar with human beings, then we know that robot was inspired in human beings. And one of the first things that human beings need, or human living things, is need to survive. Then we need to think about how will be the power source, the energy of this type of system. This is only one example of this type of challenge that we need to solve. And also my colleague from companies, there are a lot of new businesses that are open in this area. I cannot talk about the same social or governmental problem, but in fact there are a lot of new challenges in several aspects, applications, a new way to understand robots, or autonomous systems in our society now. And they are open to new ideas, new young people that can take new ideas about how to apply this type of equipment, this type of solutions for new type of applications. Not only this, they said it's industrial area, but they said it's in agriculture or in social or service area.
Okay, thank you. Another question. I was looking the faces of people here, so many undergraduate students, so it's popping up in my mind the image of my mother asking me for a rose, that Jackson's Family robot from Hanna-Barbera, that I don't, maybe you don't know it, but we, the old guys, we remember that for sure. So, when I was undergraduate student, my mother was always asking me for a rose that could solve all the problems. Professor Siegwart showed us that it would take a little bit more time for us to have a rose. But do you think that it's possible to have intelligent robots, and how smart are the robots now, and how can this evolve in 10 years or 20 years?
As an engineer, I'm actually not so interested if they're smart or not, or intelligent or not, but if they are doing a job which is helpful for society and for humans. And I think robots will rather be in situations where you don't have to be extremely smart, or at least not the smartness humans have. We should have an ideal work sharing. So robots can do the jobs which are not dangerous for humans. They should actually go into a situation where humans could be killed. All the high-level decisions, humans will be for a long time still better. But for some very precise tasks, robots are better. Imagine now, today there is hundreds of thousands or nearly 100,000 of cars built every day. Imagine that humans would have to spray paint them. This is extremely a bad environment where people should not be. Happily, we have robots. And I think there is plenty of other fields. All the mines, the gold and silver mines or whatever, there are people killed on there. If somebody has been down there, we were once down there for testing some robots. It's crazy hot up there, very bad air. Humans, these people which are working there, they survive typically, they're probably 40 and then they're dead. So I think this is, again, a field where people should not be. In agriculture, of course, hopefully at one point we can use less pesticide thanks to technology. But already today, people are exposed to this pesticide. They go by themselves out there. There should not be people there. There should be robots there. So I am personally much more interested in this line where we can really do robots which can do something. I think we should, my ambition is not to make robots which are more intelligent than humans, but robots which can be of use for humans.
Well, I can say about agriculture where I work, and I just came back from a middle of Pará state where they plant a lot of palm. They have a lot of palm plantation. Then it's the most used vegetable oil in the whole world. And I completely agree with Professor. They need robots to harvest, to crop that thing because it's crazy. The plant is very high. There's a lot of people passing out during the day because it's too hot, and the bunch are very, very heavy and hit them. So they need robots there to do this job because on this company I work, they have 5,000 people doing this work, and they have a lot of accidents every day. And pesticide is happening. Some robots are doing this job, and it's very precise. And the good thing is they save pesticide. They only spray pesticide on the weed. So they save people and they save the pesticide itself. It's less pesticide in the floor and in the water because it's go to the water after. So yes, robots. I believe robots will replace dangerous job. It's already happening. Tractors, for example, is harvested orange in here states of São Paulo. They have tractors that vibrate the tree and someone goes there and take your orange. There's a lot of example in agriculture that it's like Jetsons in agriculture.
Well, maybe outside of this science fiction image, well, there are some problems now in the new society that we will consider the age of the people are growing up, and there are a lot of countries in Brazil also are including this in case that we need to think about these old people in the house. What we will do and what type of solution we can do with robots. I also learned study about this, and it's very interesting because also is very related with this society, the culture, local culture. What will happen, what you expect when we are old, and what you expect about this type of relationship with persons or with a machine. Then, for me, it also is new interest change. For you really do a good robot or a perfect robot, or robot like human beings, it's supposed that you understand how human beings work. And, well, in my talk with some medical doctors, they do not understand very well. Then it's very there are a lot of things to do. And we have this type, we don't show it here exactly, but I know that Professor Siegwart also our work, when you have several robots, a number of different robots working together. It's also very interesting because it's like if you have the similar human beings, we have 2, 3 people or a lot of people working together. Then we have some type of social problem. And I also ask with people from human science in Brazil, they do not understand also why this type of interaction, why the reactions, why the people go to one side or another. Then also it's very interesting because in robots we need or we want to do something this. Then also Professor Siegwart talked to us. The idea is not to, or maybe it's impossible to really create a robot more intelligent than normal human beings. But if we can understand this, we can try to help some things that we are doing, and considering this local culture, develop some equipment to improve or use the better way the potential of the human beings. I think this was written in several places, but it is the way that I might think.
Okay, another question. Professor Siegwart said in the end of the presentation something about agriculture, applications of robots in agriculture and environment. I would like to hear from you, from the comparison between Switzerland and Brazil, the challenge. Is it easy for people to accept this idea? The farmers are okay about that? What do you think? How can we work to make it feasible sooner?
Of course, there is also in Europe, in Switzerland, there's always this discussion: will robots take our jobs away? I think I'm really not concerned because robots, as I have shown, it's not something which invades within 2 years or 3 years. It's a very slow process. Humans will get used to it, and there will be new jobs generated, and it's not a drastic change. Drastic changes are difficult for the societies. All of a sudden, there is millions of jobs gone, but this is not the case in robotics, I think. And there is actually a lot of signs that in a country which has a certain development, those jobs which typically can be taken by robots, humans even don't want to do. I have collaboration with farmers in Switzerland. There is only small farms, but in Switzerland we have the situation that farmers don't find people anymore for doing work on the field. So their main motivation for a robot is actually replacing people which they don't find. And there is more and more, and hear the same from Germany. They have some farmland which is actually not cultivated because they don't have people anymore. So I think there is a natural development where if it's not too fast, a society will get used and there will be more interesting jobs created, and especially also jobs which are not really somewhat abusing humans, because it's being on the field in the very sun for days and weeks. I think this is also not what is perfect for humans, and if we can have machines helping there, I think it's a perfect situation. But it has to be slow. By the way, we have also collaboration with military mines, where they have to find the mines and destroy them. There is hopefully also robots there. Today humans are doing this, and these humans doing it, they don't want robots, even if from time to time these people are killed, because that's their job today, and they're afraid. But I can assure that most of this technology will not come one to the next. So we have somewhat a generation to really learn and create new opportunities, and then robots will take some other job.
And normally they don't earn too much money to do these risky jobs, right? They spend the whole day in the sun, cropping, harvesting, and taking risks. and they receive a very small amount of money in the end of the day. And normally it's a season job, and I don't know what they do after that when they are not doing this kind of job. But the farmers are starting to using robots. We have tractors, automated tractors that they let the tractor doing the crop alone. And the big companies are using this kind of, I believe, Cases and Caterpillar, this John Deere, they all have automated tractors to do this. But they have to have someone driving the tractor, the air monitor, or inside the tractor or outside using a tablet or something in the system. The farmers are receiving well the technology, but one of the problems is they receiving too much technology to know, and they are kind of lost. They don't know what to adopt. It's too many solutions for each problem, and my perception is they are lost, and they are becoming to be afraid, to be what is the right decision to make, what the right technology to adopt. But yes, they are receiving well these new technologies, and they are receiving fast. You see in Mato Grosso, for example, there's a lot of farmers using automated tractors because they have a lot of sensors. They have more information of the farmer itself, how much they are producing, how is the harvest, what's the quality. It's all automated now.
Well, I think about the question, but there are one way of thinking. Well, the society was evolving. There are a lot of tasks that we do, and maybe robots can replace us. But now, normal sense, robots do only things that we do before. Then we need to do something, learn about this type of tasks, then put this knowledge to robot to repeat the things. Maybe in the future, maybe robot will be able to do something new. Normally, no, they do not new in this sense. But anyway, it's not the question. Well, another question is about what we will imply with the society, with employment. This is another point interesting. In Switzerland, there are a lot of high developed countries. There are a lot of jobs that the normal workers, they do not want to do, or they don't do, and then you need something to replace it. In countries like Brazil, we have, my colleague mentioned, there are really a lot of tasks that are dangerous, risky, heavy, and the people prefer to do this job because they receive some money about this, and they prefer discuss to other social guarantees about this, not about this automation, replace this work. Well, this discussion is long, it will evolve, but there are countries more developed have data about this, that people are dying about doing this type of job, and also this conscience, this awareness of Brazilian, also people like Brazil will take some time to discuss more deeply what we will do. There are a lot of jobs that really is much better or obligatory to replace the machines, but in Brazil or other undeveloped countries, they prefer to do with the risk of the life, but the people do this type of job. I really do not have an answer perfect for this question.
Okay.
what is making the people choose robots now in agriculture is a matter of costs. If it's cheaper to have a robot, it's an investment, okay. If it's cheaper to have robots doing this, then a lot of laborers, they are doing this, but they always will need people to run a farm. They won't replace everything. It's impossible. There's something people do better, something robots do better. It's a balance.
Okay, I will make my last question. Then I think we have time. You will have time to give the opportunity open for you. It's about risk taking. Professor Siegwart said that in Switzerland, people doesn't like that much to take risks, like in California, in Silicon Valley. How can the university help to solve this problem? Because the society likes innovation, but who has the money doesn't like to take risks. How can the university help on this?
I think everything takes some time. We are on a very good track in Switzerland. Switzerland was still pretty good always in entrepreneurship. By the way, because we are good, because we have a lot of foreigners coming to Switzerland with great ideas. So a lot of the newest technology in Switzerland, like the watches and so on, there were people, refugees from other countries coming to Switzerland to do this. I think it takes generations because you have to learn. If you have role models, then the next generation will do it. And I would also typically say that we should not do the same thing as Silicon Valley. They're taking too much risk. They are gambling. I think you should seriously say, I want to develop this field. It's not about becoming the richest person in the world, but having impact for the society, for the goods of the society. And I think this is even more important than just trying to use money for moving forward. And I think we are doing progress. In the last 20 years, it's really a change we see at universities. Meanwhile, I would say 50% of my students consider starting a company or being with a startup company as a real serious option. When I was a student, we never spoke about this. This was only the big corporates where you could end up, probably. Meanwhile, it changed, and I'm extremely happy to see this, because young people can take risks and can push this forward.
I will answer for Brazil, of course. I believe the main seed funding in Brazil is Participe, now with PP program. We don't have much investors taking risks in Brazil. That doesn't really exist. I'm being invested right now by a group of investment, but I was surrounded by other groups, and the first question is, what is your profit? So they are avoiding risk, right? If you have profits, you don't have risk anymore. So I believe the only institution that fund ideas in Brazil, if you are a researcher, you are a PhD student and you have an idea, you start your research in the university and you want to spin off this for a startup, I don't see other way as writing a PP project. But the biggest problem is Participe only fund in São Paulo. So the rest of Brazil, I don't know how it works. I don't know how they do. With it's your own money or other thing. But in Brazil, I only know this. And the venture capitals is even worse. They buy a big part of their company with not so much money, and they chain you in your company, and you have to work for them. You have to have profits, a lot of profits, so they sell the company after 5 years or something. But if you insist, you will find a good investor, and We are very far from Silicon Valley. There's no such thing here.
I have no much to talk about this because I'm in the university. I have my vision from the university. The main role of the university is to form, educate, create people with a good formation. In our case, engineering school will be people that will employ his knowledge to develop new things, maybe new business also, new things. But I think, well, this is the way. I think also it's like this university, this engineering school, we are more than 100 years old. And something I think that we fail in something because our ex-students are in the market, in all positions, and they create a lot of things. São Paulo is the most economical power in Brazil. There are some relationship to the University of São Paulo, certainly. But when we see all Brazil, we see that we need to do a little more. No? I don't know what we can do. People like I and a lot of professors here at University of São Paulo, we work also in Ministry of Education, some graduates, some governmental agencies, and we really have a lot of difficulty to put Brazil in a situation, in more easy way to develop new business, new technology, apply more effectively this type of knowledge. I think we do the best of we can do in our part. What we need to recognize that we need to improve this. But I don't know how the way to do this correctly.
So it's still an open question for Brazilians. We need to work on that. Now we have time for a couple of questions. Just raise your hand. I will take the microphone. Wow, lots of questions.
Hello, Professor Siegwart. In your opinion, what is today the major technical barrier for the advance of robotics and personal robotics?
I probably have an answer which is not the same as a lot of other robotics people. Some people are more coming from cognitive science or computer science. I think it's, for a lot of tasks, it's really the sensing, tactile sensing. We humans are extremely good. So imagine we can open with one hand, with our fingers, and not. I'm pretty sure that this, within the next 20 years, no robot will be able to do this. You can probably make a special machine which only can do this, but a robot which can also do other tasks. Because we have also this tactile sensing surface. And this is extremely difficult to make progress. Because biology has wonderful features which we cannot imitate. We can have motors which are more powerful than humans, but we cannot have these. And so I think there is a couple of tasks, especially thinking of the household or cleaning up. You need this, otherwise it's very difficult. And of course, the general understanding. Robots can localize themselves, but if they come in a kitchen, we immediately know this is a kitchen. Then you start to think, why do I know this is a kitchen? But there's a couple of elements, a combination. Also there we are. But there I'm more positive that this will be solved. But everything which is physical is much more difficult to solve. This takes typically much longer. I recently said in a blog, computer power is doubling every about 18 months. This is Moore's law. But battery power, for example, increase in the last 10 years, probably about 40–50%. We know this pretty well because we use these batteries for our solar airplanes, and there is no big steps. So everything which is close to physics, much closer to different elements which come together, are unfortunately very slow.
Thank you very much for the presentation and for the very interesting discussion. continuing on this discussion that you were having about robots in agriculture, my question is, so we have seen that it's good economically. It seems that it's convincing. It might be good for the people who are working for dangerous things, but do you think it's actually good for the environment? And this is going to probably be the biggest sort of question that's going to raise in the coming years. If it's environmentally interesting to do it, you give a very good example saying that we might be able to use less pesticides. But this is the example I've heard several times. I was wondering if there were other things that you can imagine by using robots, if that could be environmentally interesting and therefore becoming interesting for the society to introduce robotics.
Probably I can quickly ask, but I'm happy to hand it over then. I think the first thing what you can do with today with robots are still not so well established in agriculture. I think there is only a few places. But information is extremely valuable. The more you know about your soil, you know about the weather, you know about your development of the plants, know about diseases, I think this you can use. Now, what you can do out of this, that will be in the future. But I'm extremely convinced that this knowledge allows us to have much more sustainable farming in the future. Of course, there is also some risks. But I think all the knowledge and see correlations, and all of a sudden you say, okay, probably I have to change there something on this end so that I can get more out of my field with less bad impact on the field.
A good example is Holland. They are the second biggest food producer of the world, and they are very small. And how they can do this, the biggest is USA. But Holland is the second. It's impressive. And how can they do that? It's technology. They use robots to, for example, tomato. They use robots to harvest the tomato. They have cameras to see if the tomato is red enough. It's on the harvest points, optimize it. And what they are doing is to increasing the efficiency. They are spending less land to produce more food. And that is a big problem solution because we have a lot of people born every day and we have to feed all these people. So I believe this is a great problem solver.
So a panel is also here that to contradict some elements. I'm not so happy with the Holland or Netherlands example because this is not sustainable what they do there because they are using less land but much more energy. I think it's better what you are probably doing in Brazil is in a less extensive way because at one point food is competing with energy and this is dangerous because then on one end of the whole scale in the world people are starving and of hunger and the other side they are actually using the field for energy producing to produce tomato. I think we have to be, and this is actually the question, there is some risk that it has also the wrong direction. But once we know more, I think we can at least analyze. I think in Netherlands, it's only today that people start to think about how much energy is this needed. And then all of a sudden you have a different view. And I think it's in Switzerland, they want to have a much more diverse situation in not these monocultural situations. But for doing this, you need to know what is the best combination, what is the different fruits which you plant on the field one year after the other, and I hope we will have more and more information. And I think you are doing also this instrumentation and sensing. That's perfect.
Professor Siegwart, thank you for the nice presentation. I was very interested in the transition from research inventions to the market. We saw videos, they were very impressive, but they're mostly prototypes, and we don't see much of those robots in the market right now. I was wondering, in your opinion, what is the biggest challenge between research and production?
Yes, you are in principle true, and this is coming back to the element, it's a little bit overhyped robotics because it's complex. if you see what really strongly developed in the last 10, 15 years are drones. Why? Because drones are in principle easy. Of course, for us, the first moment, it's difficult because you have to stabilize this in the air. But this is easy for computers, difficult for us. But once you're in the free air, it's very simple to fly around. As soon as you have to go around people, it's getting more complex. So drones have made a big progress, and they are on the market. Now, all the other robots, to really be useful outside a structured and production environment, it's difficult. And I think there will not be a simple solution. There have been, actually a slide I was not active, the conclusion slide. There is also interesting elements. On one side, there are new companies bought, which are first were initiated by venture capitalists and then exited for whatever, and a huge amount. And then there is in parallel also companies which were started about 15 years ago, like Rethink Robotics, which closed their doors. They got about 150 million investments. And they had the idea to have these robots which are working outside the production hall, somewhat in a small business, easy to program, easy to adapt. It's not ready today. We are step by step moving there, but it's not ready. So we have to think about applications where it's still structured enough. Agriculture can be in some fields structured enough that you can do jobs. If you want to have the universal robot, it will fail. I'm extremely convinced. This will take another 20, 30 years until we have robots which can reasonably good do something what we can easily do. Open a bottle. Just doing this, finding a bottle, doing the screwing, in all situations, humans can do. Robots will, the next 10, 15 years, not be able to do this.
Good night, Professor Siegwart. Thank you for the presentation. And I have a question for all the panelists that is about low-cost solutions regarding low-cost platforms like Arduino and other ones that are in the market. And what are those solutions placements in the industry and how they can affect the robotics and how we view it?
What are you meaning with low-cost solution? Low-cost robot solutions, or?
Yeah, low-cost robots, because until now robots were like highly costed. Motors are like expensive and sensors are expensive, and from the past 10 years we've seen solutions that microprocessors that are getting better and better and less expensive, and that they can perform more complex tasks. So how this can affect the market?
Also there are some people which think, mainly coming from computer science, that now robotics will do the same. I think, again, physics, it will not so immediately become low cost. If you have to generate a force, a certain force, you cannot make jumps. A motor is somewhat limited power density, and there is physics. You can say that you cannot have all of a sudden 10 times the power in the same motor. And then you have the windings, which is copper, and you have the physics, and copper is not all of a sudden 10 times less cheap. So all the stuff we have learned from computers, mainly computers and memory, are not applicable to other fields. So there is no low-cost solution so easy. It will become lower in cost, but mainly because you scale the numbers. Drones are today pretty okay in the price. If you imagine, DJI drones are still not cheap, but they did a huge amount. You get a beautiful element. Cars are also examples of getting lower and lower in cost, but the car is still something which has a lot of mechanics in it, and you even think of material cost. Try to buy only the material by kilogram what you use in the car. If you buy it probably individually, it's about the price of a car, without even a treatment of the material.
This type of measure is a little difficult to do. If you think in industry, the cost of the robot will be considered how will be the profit which you do in the process which you put in a robot. If you think only the mechanical part of the robot. I think if you can work with 1 or 3 kilograms, maybe the mechanical part will about the cost of one car, one small car in Brazil. But it's like a computer. It's only the mechanical part, and the operation system and the computer and the sensors. Well, depends of the work, it will be much more, several times the price of this mechanical part. But we will change. You think about, you know, I think the first pet robot was a dog that Sony, I think the name is Aibo. Remember? Aibo. When he launched, it's $4,000. It's a little expensive, maybe. $4,000 for a pet robot. But nowadays, you have some pet robot. It's much more simple than Aibo, but I think $200 or less. Well, it's not like the Aibo, but it's a pet robot. Then, because your question, there are a lot of ways to think. I don't know if you answered your question.
What you have to do is to calculate the payback. For example, I have a product that costs 80,000 euros, and the client pay it in 5 months. The rest of this, it's earning money. So the high cost depends on the problem you are solving. In our case, we are increasing the efficiency of the oil extraction. So the client is producing more and is making more profits and paying the solution very fast. So the cost depending of the problem you are solving, the profits you are increasing, this has to be calculated.
Hi, Professor. I see something that you say, that video about the castle that wasn't there. I think, how you think that it will affect the society at the moment when we can have that technology in our daily life? Because think about that. If you can do this palestri, and you never get to Brazil, because we put a glass and see you like you are sitting there, and it's like common, the daily day.
So you speak about more or less telepresence. Yes, it's also interestingly pretty slow. Honestly, I think I would be happy to see more this really well-functioning telepresence systems where you can actually, you don't have to go to a conference, but you can watch a conference at home, because it's also more sustainable. Flying all around only for listening to 2 talks is sometimes a little bit stupid. But you know that, of course, also there, it's not only the presence, it's an image. But if I'm here in Brazil, there is smells, there is sounds around, there is actually physical interaction with people, shaking hands with people. And I think this you cannot so easily have. And for a lot of relationship, also business relationship, you have to be physically in the same room at one point, or the same environment, so that you can feel. And I think this is special to humans, which is actually nice. I assume robots will never have this. But we humans want to be physically there and really see this. And so we'll see how long it will take, but it's coming back to the physical feedback. So there is also some ideas that you have somewhat a data glove that you can feel on the other end what the interaction. But this progress is also extremely slow, as mentioned before, this tactility. Follow up? Just shout it out. Yes, that's probably a more philosophical question, how society will develop. I hope it's in a positive sense. I hope this technology will help us to have a better life, which probably more interaction with other humans and not a more isolated life. But it can also happen, and that there is probably some, in some direction, but I'm not so pessimistic. So I see young people just still interacting, even if today we have totally different ways to interact. But I don't think that people are less interacting today, but they have new tools to interact. They are more connected with friends. I'm personally extremely happy to have WhatsApp so that I can actually interact with my family when I'm here. This is a new way. Some people say this is not a real way, but it's actually still a real interaction.
So the last question now.
I have the honor of the last question. Thank you very much. My question would be a little bit more foot on the ground. As you started mentioning and you pointed directly at one of the, let's say, bottlenecks of robotics development, that was about the tactile sensing. And I would like to have an overview of the different bottlenecks in the whole robotic system. You say tactile technology, that is measuring forces and positions to implement impedance control, because robots that interact with people will need this kind of control, as you mentioned. But maybe we could also take a look at the actuator systems. You showed some series elastic actuation, probably in series with DC motors. That's probably most used technology. And maybe I would like some ideas about this, what are the bottlenecks we should focus on to improve to advance robotics?
Yeah, probably there is a lot of bottlenecks because robotics is a systems technology. And probably one big bottleneck is that you have to bring all this together. For example, robotics research, we had this discussion. What I learned is that in Brazil, professors are somewhat limited in the number of students they can have. For robotics, this is a tough issue because I have a pretty big group, and I think it's needed because robotics we need people which bring sensors and actuators together with intelligence and mechanics, and you have to have this somewhat at least close together. Otherwise, you cannot make progress. So that's one challenge with robotics. I think on the actuator side, I see that electric motors, DC motors, are, for a lot of applications, extremely good. Gearboxes are good. Now the patents failed. The patents were running out. And now the gearboxes are getting cheaper. That's actually good for robotics. I think there it's not so. But of course, sensing, and then, of course, the whole intelligence in some, dependent on the application. But it's really the complexity of these systems so that they can understand. I think there is no single machine which has any capacity that you just tell them, clean the floor or whatever. So, of course, where a dedicated machine, you can push the button and then the machine is cleaning. But if something is different, we have no way to teach as a robot. Also in industry today, by the way, there is also some progress to make there, because these machines have to be installed by specialists, and then you have a production line, and if you want to change, it takes for at least a couple months to change it. That's the reason why a lot of products are still not produced by robots. For example, smartphones. There is two issues. One, because it's very small, tiny, again, tactility, but on the other side also the production line changes too fast. Humans can learn within 1 day to produce and assemble something different. If you want to do this with robots, you have to have specialists to program these machines to do the new job, even if the housing is only a little bit different. And there is, I think, there's plenty. I could probably list endless challenges. But
So now, Sylvia, please.
Do you have anything else to add? So let's now thank you for the very fruitful discussion. Thank you for interacting, and please join us. We now have another chance to interact among ourselves outside. And thank you for coming.